It is not a violation of electrical code to wire 3-way and 4-way switches utilizing two 2-conductor non-metallic sheathed cables instead of a single 3-conductor cable. The National Electrical Code, or NEC, provides guidelines for safe and compliant electrical installations, and this particular wiring configuration is generally permissible, provided all other requirements are met. The fundamental principle guiding electrical installations is ensuring safety and functionality. The NEC outlines specific regulations for wiring methods, conductor sizing, overcurrent protection, and grounding to minimize the risk of electrical shock, fire hazards, and equipment damage. When wiring 3-way and 4-way switches, the primary objective is to control a light fixture from multiple locations. A 3-way switch has 2 traveler terminals and a common terminal, while a 4-way switch has 2 pairs of traveler terminals. The 3-way switches are installed at the beginning and end of the switch sequence, with the 4-way switches placed in between if there are more than 2 switch locations. Utilizing two 2-conductor cables offers an alternative to using a single 3-conductor cable for carrying the traveler wires between the switches. This approach is acceptable as long as each cable is properly installed and meets all the applicable code requirements. Firstly, the conductors within each cable must be of the correct size based on the circuit's amperage rating and the ampacity tables provided in the NEC, such as Table 310.15b16. This ensures that the conductors can safely carry the intended current without overheating. Secondly, the cables must be secured and supported properly along their run, in accordance with NEC Section 334.30. This prevents strain on the connections and protects the cables from physical damage. Thirdly, all connections within the switch boxes must be made using approved wiring methods such as wire connectors or terminals listed for the purpose. Proper connections ensure a secure and reliable electrical path. Fourthly, the grounding conductor in each cable must be properly connected to the grounding system, providing a low impedance path for fault current. This is crucial for safety and helps to prevent electrical shock. Fifthly, the cable must be protected from physical damage where it is exposed, such as in unfinished basements or attics, as required by NEC Section 334.15. This may involve running the cable through conduit or using guard strips. Sixthly, the cable must be installed in a neat and workmanlike manner, as specified in NEC Section 110.12. This includes avoiding sharp bends, ensuring proper cable routing, and maintaining adequate spacing between cables. Seventhly, all splices and terminations must be made in approved enclosures, such as junction boxes or switch boxes, in accordance with NEC Section 300.15. This protects the connections from environmental factors and prevents accidental contact. Eighthly, the wiring must comply with any applicable local amendments to the NEC. Some jurisdictions may have additional requirements or restrictions on wiring methods. Ninthly, the integrity of the neutral conductor must be maintained throughout the circuit. The neutral conductor must not be interrupted by any switching devices. Tenthly, the wiring must be inspected and approved by a qualified electrical inspector. This ensures that the installation meets all applicable code requirements and is safe for use. While using two 2-conductor cables is permissible, there are a few considerations to keep in mind. Firstly, it may require more labor and material compared to using a single 3-conductor cable, as each cable needs to be individually installed and terminated. Secondly, it may result in a more crowded switch box, especially if there are multiple switches and cables in the same box. In such cases, careful planning and wire management are essential. Thirdly, it's important to ensure that the conductors in each cable are properly identified and labeled to avoid confusion during installation and future maintenance. The white or grey wire within the cable should be consistently used as the neutral, while the other wire should be used as the hot or traveller conductor. Fourthly, the use of two 2-conductor cables may increase the overall cost of the installation, depending on the price of the cable and the labour involved. It's advisable to compare the cost of using two 2-conductor cables versus a single 3-conductor cable to determine the most economical option. Fifthly, the ampacity of the conductors must be suitable for the intended load. The conductors must be sized appropriately to carry the maximum current that the circuit is expected to draw. Sixthly, the cables must be protected from physical damage. The cable should be installed in a way that minimizes the risk of damage from nails, screws, or other objects. Seventhly, the cables must be properly supported and secured. The cable should be supported at intervals specified by the NEC to prevent sagging and strain on the connections. Eighthly, the connections must be made in a secure and reliable manner. The wire connectors or terminals used to make the connections must be listed for the purpose and must be properly tightened. Ninthly, the grounding system must be properly installed and connected. The grounding system provides a path for fault current to flow back to the source, which helps to protect against electrical shock. Tenthly, the installation must comply with all applicable codes and regulations. It's important to consult with a qualified electrician or electrical inspector to ensure that the installation meets all requirements. In summary, using two 2-conductor non-metallic sheath cables instead of a single 3-conductor cable for wiring 3-way and 4-way switches is not a code violation, provided that all other applicable requirements of the National Electrical Code are met. These requirements include proper conductor sizing, cable securement, connection methods, grounding, and protection from physical damage. Always consult the latest edition of the NEC and any local amendments to ensure compliance with the most current regulations. A qualified electrician can help to ensure a safe and code-compliant installation.